Hi, I'm Professor Clements, and today we're going to be talking about how do we get numbers from scientific notation into what we call decimal form, or just regular old form. We had a couple of videos so far where we talked about how to take a big number and turn it to scientific notation by moving the decimal point over and counting, and also taking a small number, something less than 1, and converting it to scientific notation. But what if someone gives you some scientific notation and they say, hey, I've got this number that's 3.08 times 10 to the 8th, and there's usually units on there, so let's put some units on there. 3.08 times 10 to the 8th meters. Well, what does that 10 to the 8th mean? Remember, 10 to the 8th just means 10 times 10 times 10 times 10, 8 times. Right? That's what 10 to the 8th means. So all I need to do is take my 3.08 and multiply it by 10, and multiply it by 10, and multiply it by 10, 8 times. And what does that do? Well, it turns out multiplying by 10, right? All it does is move the decimal point over. So what I'm going to do is I'm going to move the decimal point over 8 times. So I'm going to write my 3.08 down here, and I'm going to move the decimal point over 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And you're like, there's no spaces there. And it turns out when you're doing this, right, we've got a positive exponent. We know positive exponents are big numbers. It's something to keep in mind. Positive exponents tend to be big numbers. We're going to fill in all of these with zeros. Now, I said I'm moving the decimal point over. I'm not actually going to put a decimal point there. And the reason is because if I put a decimal point, all those zeros become significant. And our scientific notation had 3 significant figures to begin with, so we need to have 3 at the end. So the number we end up with is actually 308,000,000, which, if we add our commas, is 308 million. And that's how we're going to convert from a scientific notation to a regular number with a big exponent. With a small exponent, it's pretty similar. 2.050 times 10 to the minus third. Well, what does that 10 to the minus third mean? Whenever you see a negative exponent on that 10, you should be thinking that you're going to have a really small number. Okay, so we're expecting a number to be less than 1, which means we need to move the decimal point over to the left. And how many spaces? 3, right? That 10 to the minus 3 means we're dividing by 10 to the third. We're dividing by 1,000. So I'm going to take my 2.050, put it in here, and I'm going to move the decimal point over 1, 2, 3. Now here, I actually do want to move the decimal point. I'm going to move it from here. I'm going to actually change it over there. Any blank spots I need to fill in with zeros. I always like to have a 0 before a decimal point because it makes it clear that you're dealing with a number less than 1. And so without the smooches, we end up with 0.002050. And we have to be careful about our significant figures. Since we started with 4 significant figures, remember those trailing zeros are significant because there's a decimal there, then we need to end with 4 significant figures. You're never going to change your number of significant figures when you're changing from scientific notation to a decimal, or the other way around, from a decimal to scientific notation. Okay. So hopefully we've got a good sense of how to do scientific notation now. Again, it's very important. We use it all over in chemistry and all over in science. Thank you.